Hello all, welcome to the lecture series of automotive systems. Today we are going to see about the traction control system. Traction is the thing where is very much important, and it lies between the grip of the road and the grip between the road surface and the tires. So that is nothing but traction. So this is a block diagram of a traction control. So the traction control is equipped in the vehicle in order to avoid the wheel slip during traction, because the road grip is very much important in that point of traction. So the vehicle should not have wheel slip. If there is a wheel slip, means the vehicle motion will not be stable. So the uniformity will be lost, and the vehicle may be out of control, especially in the off-road conditions. So that is why we use a traction control system, that is simply called as track. This track control system is used by the application of brakes. So the brake is applied where there is a excessive wheel slip is identified. So this is the block diagram of the traction control system. You can see here the wheel speed sensor, the battery level, the track on off switch, the stop light switch, throttle position sensor, the electronic or engine control modulator, the electronic control unit. It is a combination of track, that is a traction control system, that is electronic stability control system, and the anti-lock braking system. So that is the three things you can see here: TRAC, ESC, and ABS. And the next is the actuators. The actuator here is the solenoid, the pump motor, the slip indicator light, and the ABS warning light. So these are the major components of the traction control system. So the throttle position sensor is nothing but the input, and it is processed by the ECM, and it controls the injection pressure so that the fuel is supplied in exact quantity required. The components of the traction control system is the ECU, that is electronic control unit, and the DC-DC converter. The next thing is the sensors, that is the yaw rate, the pitch, then the rolling. All the things will be pitch, yaw, roll. The three motions will be monitored by using the sensor. This sensor input is very much important. So this is called electronic stability control unit. So this is a combination of pitch, yaw, roll sensors. And in the traction control, you can see here the traction control is nothing but the wheel speed sensor and the braking unit. So the both will integrated by means of the traction control system. So this wheel speed sensor and the braking unit will be monitored and actuated according to the need. So that is what the traction gear. So this is a wheel slip. You can see here the one end, on the diagram. The one end is having a good surface at the bottom, whereas the right hand side wheel is subjected to a slippery or rainy or a water, the surface with water. So what happens is there will be a wheel slip. So in this case, the differential unit supplies less power to the slipping wheel and the more power to the wheel which have good grip or the traction. So this is what the application of traction control, and you can see the traction off and the traction on. The vehicle which goes out of its path on the left hand side. So that is because there is no traction. And on the right hand side, you can see the vehicle is able to turn with stability. That is because of the good traction effort. So this is how the traction on off condition. When the traction is on, the vehicle can able to steer properly, apply brake, and the control is within the vehicle. You can see in between the divider lines, you can see how the vehicle is subjected to change its direction. When the traction is off, you can see here the vehicle motion is out of control, and the vehicle because of poor steering and braking, the vehicle loses its control, and it changes its direction straight opposite to the direction of travel. The understeer and the oversteer concept is very much important. The ESP stands for the electronic stability program. The understeer, you can see the vehicle goes out of its path. than the desired. For example, 3 meter radius turn means the vehicle turns for 5 meters. That is understeer, and the oversteer is the radius of turn is somewhat 5 meter, and the vehicle turns within 2 meters. That is the oversteer. So these things will be monitored by the electronic stability program. That is a PCR roll sensor, and the brake is applied in the accordance to the required motion. So this is very much important in the racing vehicles, because a very high speed vehicle that goes around 180 or 190 kilometers per hour, more than that, suddenly controlling the distance or the suddenly controlling the changing the direction is very much important. So this traction control plays a major role in the sports vehicles. So the major advantages of this system is to avoid accidents and the twists and turns, the slipping of wheels, the stopping distance, and the driving a powerful car. As I told already, a sports car, and the grip is very much important. That's it about the today's lecture, and let us meet on another lecture. Thank you.